Geometry Chapter 8, Lesson 4, and now that we know what the sine and cosine ratios are, let's do a few problems where we apply those. Now, a quick process or few steps that you should use when you're using any trigonometric ratio is to be able to choose the correct ratio, and so you'll need to have a procedure in place whereby you can do this. So here's what I do. And you can use the same process or come up with one on your own as long as you are choosing the correct ratio and then applying that ratio to the problem. First of all, I'll look and I'll choose one of the two acute angles that is given. If both are given, then I can choose either one. The only thing I have to make sure is that I don't choose the right angle, because the trigonometric ratios that we're using will only work with the acute angles. Once I have chosen the angle, then I'll look at the sides that are given and the sides that are missing. And I'll decide based upon which one is given and which one is missing, whether they're opposite of the angle that I'm looking at or adjacent to the angle that I'm looking at, or whether it's the hypotenuse. And based upon that information, I will choose the ratio that involves the side that's given and the side that's not given. Once I've decided which ratio to use, I simply substitute in the values, the angle for the angle measurement, the side that I know in for the side, and the side that's missing in for the other side. And once I've done that, I simply solve the ratio algebraically, or if I'm looking for the angle, we'll use the inverse function in order to determine the missing value. So the rest of the video, I'm going to do a number of examples using this process. If I'm looking at number 4 here, the first thing I want to do is I see here that they've given me angle 35. And now I want to look at this information that's given in relationship to that angle. I notice that the side opposite 35 is the one that I'm asked to figure out, and the measure that they give me is opposite the 90, so that is the hypotenuse. So I want to think about which ratio then involves an angle measurement, the opposite, and the hypotenuse, and that is the sine ratio. So I'm going to use the sine ratio to solve for this missing length. I then repeat the ratio and then substitute in the values that I know. So the sine of the angle, in this case is given to me as 35, is equal to the opposite side, which is x, over the hypotenuse, which is 20. I then have my ratio, which I solve algebraically. I'm going to multiply both sides by 20 because that's going to reduce this side to 1. So this is going to be 20 times the sine of 35. Now, this would be my exact answer. This here says to round to the nearest tenth, so I'll have to calculate from here. Because it asks me to round it to the nearest tenth, I'll use my calculator and I'm going to enter in what I see here. So it's going to be 20, and then we'll use the sine of 35. And that gives me 11.47. I'm rounding to the nearest tenth, so I need to put 11.47. And then that tells me then that this would be about 11.5 would be the value of x. Again, make sure you use the approximately equal sign. Make sure you go one past the place that you're using, and then make sure you have your final answer using tens place. And we check that and we have 11.5. Let's do a couple more examples. I'm going to do number 9 down here just so you can see. Here I have a choice because both the value of both angles are given to me. If I decide to use the angle 28, then I'm looking at the opposite side, which is 50, and the hypotenuse, which is x, so I would use sine. So if I use the sine of the angle 28 is equal to the opposite over the hypotenuse, and then I would solve this. So multiplying both sides by x so that that reduces, I'm going to have x times the sine of 28, and remember the sine of 28 represents one value, so I would put it in parentheses so I don't forget, and then x would be equal to, dividing both sides by the sine of 28 would give me the sine of 28, and again this would be my exact answer. Now let's say I decided to use 62. Well, if I use the 62, the 50 is now the adjacent and the x is the hypotenuse. So in this case, I would use the cosine ratio. The cosine of 62 is equal to the adjacent, which is 50, over the hypotenuse, which is x. And then I would go through the same algebraic process to solve for x, multiplying both sides by x and then dividing by the cosine of 62. And you remember when we were talking about the sine of one angle and the cosine of the other being the same, so I should get the same value if I do this. So let's take our calculator and calculate them and see if we don't get the same answer. So first we have 50 divided by, and we're going to divide by the sine of 28, so we'll use the trigonometric sine 28, and we're going to calculate that. And so that's going to give us 106.50. So writing that down, x then is about 106.50. And I don't think that's going to be right, but x would be about 106.5 then. Well, that'd probably be about right, because that's 50. I was just thinking out loud there and didn't really think correctly. And let's do the cosine and see if we don't get the same answer. So the cosine was 50, and then it was divided by, and in this case we want to use the cosine of 62. And if we enter that, you'll notice we get the exact same value, 106.53. So you can see that whether you use the cosine or the sine, you'll arrive at the same answer. And again, that kind of shows what we talked about earlier, that the sine of one angle and the cosine of the other are the same. And so once you know one ratio, you have the other. I'm going to do an example or two where we have to determine the measure of the angle. Now, when the angle is unknown, the process is all the same. The only thing is that when we go to solve for x, we're going to have to use the inverse function in order to solve for the x, because there's no way to algebraically solve that. So in number 11 here, again, I locate the angle. I look at the side that's given to me. This is opposite and this is adjacent. So again, I want to use the sine ratio. So the sine of the angle, which in this case is unknown, is x, is equal to the opposite side, which is 5, over 14. See, not 15, 14. And because the angle is what's unknown, I need to use the inverse sine function, you remember, 5 over 14. Now again, this would be my exact answer. They want me to round to the nearest degree, so I will calculate that and then determine that. So in this case, I want to use the inverse sine. So we choose the inverse sine, and it's 5 divided by 14 is my ratio. And I enter that, and I get a 20.9. Now I'm rounding to the nearest whole angle. Whoops. So that's 20.9. So x is about 20.9, and then because that's a 9, we're going to round up. So that's about a 21-degree angle given those sides. And so if we find we have that. Okay, let's do one more of this type, and then we'll wrap this up. We'll go ahead and look at number 16 here. Again, I have the angle. This side is the adjacent side, and then this side is my hypotenuse. So adjacent and hypotenuse involves cosine. So I'm going to use the cosine ratio. The cosine of the angle, which is unknown, is equal to the adjacent side, which in this case is 0.15, over my hypotenuse, which is 0.37. And then I would solve this. And again, because the angle is what's being determined, I'll need to use the inverse function, and then I do 0.15 over 0.37. Now, I'd like an exact answer, and I don't like decimals in my exact answer. In a fraction, it's either a decimal or a fraction, so we'll just simplify this by moving the decimal point over 2 places. So this would be my exact answer. But again, because it asks me to do this to the nearest degree, I'll use my calculator. So again, we need to use the inverse function. So it's the inverse function of cosine of 15 divided by 37. And that's going to give me a 66.0 approximate answer. So x is about 66.0. So that's about a 66-degree angle after calculating that on my calculator. Okay, so again, choosing the correct ratio is the key to this, remembering the ratios, and then all we have to do is determine which one to use, substitute in the values, and then solve for the missing variable.